Hello guys, we are now looking at 1A.2. Our mastery learning objective for today is I can simplify an expression by using addition and subtraction to combine like terms. So I hope we all know what an expression is, right? Since we just went over that in our last video. I hope we all know what addition and subtraction is. So the only part that might be new to us is what is combining like terms. But we should still know what the word terms means, right? So those things that are separated by addition and subtraction. That makes sense. So we need to know what like terms are and how to combine them. Okay? So that's the first vocab we're going to look at. What are like terms? Like terms are terms whose variables and their exponents are the same. Okay? Variables whose terms and exponents are the same. So then what does it mean to combine like terms? Combining like terms is simply simplifying an expression by adding or subtracting those like terms. Then, the last thing we need to know is what standard form is, because all of our answers need to be in standard form. And standard form is just a polynomial. And what is this word polynomial? Well, just like monomial, binomial, trinomial. Those are all very specific. A monomial has 1. Binomial has 2. Trinomial has 3. You can go on from there. A polynomial is just how many ever terms. So a polynomial is just an expression with whatever amount of terms. It's our general name for them. So a polynomial is in standard form when its highest exponent is first, and then continues in decreasing order. Constants last. So an example, I can have x to the 4th plus 4x cubed plus 2x plus 3. Okay? Again, it's based on your exponent. X to the 4th is first because 4 is my highest exponent. And then 3 is my next highest exponent. Then this one doesn't have an exponent. It's technically a 1 there. And then our constant, what if it's a constant? It will always come last in standard form. Okay. All right, so let's look at what actually combining like terms is. When adding two numbers with the same base and same exponent, you add or subtract the coefficients. So I want to look here. Do I have the same base? Yes, these are both an x. Do I have the same exponent? Yes, they both have an 8. So I need to add or subtract the coefficients. So what's my coefficient on this one? It's a 1 because it's not there. Same thing here, it's a 1. So 1 plus 1 is 2. And then the only thing that changes is your coefficient. The exponent and the base both stay the same. All right, looking at number 2, do they have the same base? Do they have the same exponent? Yes. So now I'm just subtracting, right, because this is subtraction. What's 5 minus 2? 5 minus 2 is 3, and then x to the 4th. That easy. I should square these. I don't actually like circling. So 3x to the 4th. Done. Let us look at example 3, 2a plus 3b minus 4a. So I have to look for my like terms. My base or my variable needs to be the same. If I look here, I have an a. That's not an a, that's a b. And this is an a. Okay, so those are the same, but this b is different. Okay? So I can only combine the ones that are the same. So I'm going to combine 2a and negative 4a, or 2a minus 4a. Remember, the sign always goes to what's to the right of it. So 2 minus 4 is negative 2a, right? Just the coefficient changes. Then this 3b, right, that b has nothing else to combine with it, so I have to still just write it, but it doesn't get added or subtracted. Okay, it's just negative 2a plus 3b. And that is my final answer. Why did I write it like this? Why did I not write 3b minus 2a? Your variables are going to go in alphabetical order. It's just kind of another standardization thing so that everyone gets the same answer. Even when things can be written different ways, it's good to have a standard. All right, looking at example 3, 2x to the 6th plus 5x to the 6th. They have the same base. They have the same variable. I'm just adding 2 plus 5 is 7. X to the 6th. Done. If we look at this one, they all have the same base or the same variable, but this one has a 2. These ones don't have a 2. So, 3x squared is a term by itself. Okay? I've used that. Now, 4x and 5x are like terms because they both have the same variable and then don't have exponents. So 4 plus 5 is 9, and that variable stays the same. So I'm left with 3x squared plus 9x. All right, looking at our last one, right, I have an m, then I have some n's, then I also have some exponents on some of those n's. Okay. So where are we going to start? We have to start with our highest exponent, okay? So these are the only ones with an exponent, so I'm going to start with the negative 3n squared and negative 2n squared. Negative 3 and negative 2 gives us negative 5n squared. Okay. What am I going to use next? Well, m and n, these last two terms, these remaining terms, now that I've used, let's cross them out so I know I've used them. right? Both don't have exponents, so then I have to go by alphabetical order. M comes before N in the alphabet, so it's just plus 14M. Done with that. Then I just have minus 3N. Done with that. Okay. And that is our final answer. All right, that is it for 1A.2. Go ahead and choose if you're going to do uphill, straight ahead, or mountainous, and start working on the 1A.2 activity.